So we are now moving into out of law signs, out of law cosines, and going into all those different formulas that are on the board. There are a lot of them. So we are doing the sum and difference formulas. And if we have time, we'll get into the double angle formula. So that's probably all that we're going to be able to fit in here in the last few days. Alright, so here is the sum formula. So if I have sine of two angles, we'll call them A and B. It doesn't matter what they are. We are going to take the sine of the first thing and the cosine of the second thing and add that to the cosine of the first thing, the sine of the second thing. Right? Now these are all memorized category. You need to memorize them. Cosine of A plus B. It's pretty similar, except instead of add, we're going to subtract, and it's going to look like this. Cosine A, cosine B, minus sine A, sine B. Again, you need to memorize. Whatever it takes for you to memorize these, whether it means you put them on a flashcard and you read them to yourself, or you write them a million times. If you write them each time you use them, then that will definitely help. And finally, tangent of A plus B equals tan A plus tan B over 1 minus tan AB. Like this. So those are our sum formulas. We're going to go ahead and do an example problem of what we might use these for. So let's say that I wanted to find the sine of 75 degrees exactly. Well, we would know, and let's get out a calculator here just to help us. We know that the sine of 45 is root 2 over 2. And if you don't know that, that's something that you want to memorize. And we know that the sine of 30 equals what? If you don't know, put it in your calculator. 0.5 you said? So that's a half. Okay? So, if I want to find the sine of 75 exactly, what I'm going to do is I'm going to say sine of 75 equals the sine of 45 plus 30. See, that's a sum. And then from there, I'm going to use this sum formula. The sine of 45 times the cosine of 30 plus the cosine of 45, the sine of 30. Now,
45 and 30 is just 45 plus 30 is 70.
Yeah, the 75 is 45 plus 30. These are thinking where you have to split up the angle somehow. Now, the cosine of 45 happens to be root 2 over 2, and the cosine of 30 is root 3 over 2. So, again, if you don't know those would be something to memorize. Sine 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. Sine of 30 is a half. So then when we simplify this, remember we multiply before we add, so we get root 6 over 4 plus root 2 over 4, which these have the same denominator, so I could combine them, and I get root 6 plus root 2 all over 4. Now if you're working on a Casio calculator and you put in sine 75, it actually should pop this out. So you can use that to check your work. If you don't have one, you're going to have to rely on your intelligence in order to make sure that you're doing these right. Now that's not the only thing that we could use a sum and difference formula for. Maybe we are given a ratio. I'll give you a moment to copy that down. Okay, here's another thing that we might use it for. Suppose sine of some angle, we'll call it A, equals 3/4, and the cosine of some other angle is, say, 4/5. So we have two different angles here that we're talking about. Let's find, well, first, I'm going to have several questions here. Let's find cosine of A. Let's find number 2, sine of B. And then third question, let's find, well, what is the sine of A plus B? And what is the cosine of A plus B? So this is formatted more like the question that you would be asked. Now, 1 and 2 here would actually not be asked. These are steps in order to answer questions 3 and 4. You would have to know to do these 2 steps first. Here's how we know. I'm actually going to start on number 3. Let's say I wanted to figure out what this is. Now, I don't know what angle A is, nor do I know what angle B is. All I know is these ratios right here. So if I wanted to figure this out, I have to use my sum formula. Sine of A, cosine of B, plus cosine of A, sine of B. Now I know sine of A, don't I? It's 3/4. So I'm going to put that fraction in. I know cosine of B. That's 4/5. I put that in. But notice now I need the cosine of A, and I also need the sine of B, but I do not have either one of those. So from earlier in trigonometry, you should know, well, that's not going to be the type of triangle I want, so I guess I'll just have to draw it by hand. I'll draw a right triangle. And I will use the ratio of sine and cosine in order to figure this out. Now I'm going to need 2 of these triangles. So let's do number 1. Let's find that cosine of A. Let's say this is angle A right here. Well, sine is opposite over hypotenuse. I just draw my triangle. Whenever you're missing one of these, if I give you a ratio, you should be able to find out all the other trig functions by drawing a right triangle and figuring it out. Now I need to get this side. Now we're finding this exactly. So what can I use to find this missing side? Yeah, Pythag. So this side, whatever we want to call it, we could call it side x. X squared plus 3 squared equals 4 squared. X squared plus 9 equals 16. Subtract the 9. X squared equals 7. X equals root 7. So this is root 7. So cosine is adjacent over hypotenuse, right? So cosine of A is root 7 over 4. Now look where I can use that. Down here, right? Do you see the connection I'm making here? So this is root 7 over 4. See, number 1 is a step to finding number 3. Now I need to find sine B. Well, that's number 2 here. Now I'm not going to necessarily be asked these first 2 questions. They are steps in order to get this. Alright, so sine of B is, well, I need to fill in this triangle. So if this is triangle B, 4 is opposite or adjacent? It's adjacent. So what's the 5? Alright, now this is, hopefully you're so used to a 3, 4, 5 triangle. Whenever your hypotenuse is 5 and one of your sides is 3 or 4, the other one's the other number. So Pythagorean triple is like the most common one in the world. But you can get that by Pythagorean's theorem. So what's sine then? Sine of B? 3 over 5, right? And then I can use that down here. Now sometimes your denominator is different, but in this case it's the same. So 20. And what's 3 times 4? 12. Plus, see, now I could do this because I already have a common denominator. Do you see what I'm saying?
Well, I do 3 times.
Huh? 3 root 7?
No, over here I want to need like 15. Because 5 times 4 is 20.
5 times 4 is 20.
Yeah, but you have to multiply the 3 back. 4 because it's not straight angle.
Wait, you're on that side now.
I'm confused.
Nothing.
Okay, well let's do it in steps then.
Go.
Okay? If I multiplied this fraction, I get 12 over 20, right? Plus, if I multiply this fraction, I get 3/7 over
Oh, you're just doing it.
20. These have the same denominator, so I can combine them into one fraction, which is what I was doing. Your denominators aren't always the same, but in this case they were, so it was easy to go ahead and do that. Now number 4, we've actually already found all this out. Now we do have a different formula here. This equals, and let's just take another look at it, cosine A, cosine B minus, so that's a little difference, it's a sum formula, but there's a minus for the cosine sum, and then the sine. So this equals cosine A, cosine B minus, I said B, but I wrote an A, sine A, sine B. Alright, so cosine A, we figured out is root 7 over 4. Cosine B we were given. And sine A is 3/4. We were given that. And sine B we calculated as 3/5. And then now I'm going to go ahead and write this as one fraction. Do we see that our denominators would be the same? 4 root 7 minus 9. And that is this exactly. The whole point of using sum and difference formulas is to be able to calculate sines, cosines, and tangents exactly. That is essentially its only use. Other than identities, we probably won't prove any identities with these this year, but next year you will. We'll just use them for this year. Let's do one with decimals. Are we good? Is anyone completely, utterly lost?
I mean, I'm not lost, but
You want to copy it?
yeah.
We're going to do one more of each of these before we get to the difference formula. And I can't stress enough, memorize the formulas. Right? Memorizing your life is a lot easier. And then when we do it next year in pre-calc, you won't completely freak out because we'll go a lot faster. I'm going to give you a heads up. I know you're going to hate me, but I don't care. You are going to have summer homework if you're taking pre-calc. Just get yourself ready for that. This year's pre-calc class had it, and you also will have it. You'll have summer homework. Because we have to know certain things in order to learn pre-calc effectively. Won't be too much, but just get your heads prepared. That Mr. Kane's a meanie head face. All right, let's say, suppose let's say cosine of A is negative. I said we're going to use decimals, but I guess we won't. Not yet. Negative 1/5. And cosine of B, let's say, is negative 2/3. And we'll say both angles are in quadrant 3. Now this is an important extra piece of information here, because this tells me whether sine is negative or positive. Now the other one, I didn't give you that. These were both positive, and since they were both positive, I mean A would have to be in quadrant 1 and 2, and B would have to be in quadrant 1 or 4. So we assumed right here, so we assumed on this one that both of these were quadrant 1 angles, which isn't that unreasonable of an assumption since they were both given to us as positive ratios. But here, we need this extra piece of information so we know whether sine is negative or positive. So if we're in quadrant 3, is sine negative or positive? Negative, right? Think, we're down here, right? So cosine's negative and sine's negative. So I'm going to just write this question. We're going to find sine of A plus B. And we're going to also find cosine of A plus B. Now this time I didn't give you the intermediate step, but what do we need to know? Well, as I write out my sum formula, this is going to equal sine of what? Cosine of, what's the symbol here? Plus what? Cosine, sine. It's easier to remember by keeping the angles in the same order and then switching where your sines and cosines are. So I'm missing sine A and sine B, aren't I? So I'm going to draw, what do I do? Draw a triangle. I'm going to need two of them, right? This is A. This is B. Make sure I have my right angle there. Okay? Now, I'm both of these are given cosines, so this is adjacent over hypotenuse, right? So I have this, right? I'm just going to leave those as positive, just so we don't get confused, but, I mean, technically they're negative. Alright, now I need to find in each of these x, right? So what do I use? 5x. So I have 1 squared plus x squared equals 5 squared. 1 squared is 1, so x squared equals, this is 25, so 25 minus 1 is 24. And x equals root 24. We're going to need to simplify that to 2 root 6. Alright, we do this one. We'll have 2 squared plus x squared equals 3 squared. So this is 4 plus x squared equals 9. We subtract that 4, get a 5, and x equals root 5. Now, what does that mean for sine? Well, then sine of A. Now we need to remember, this is why we thought about this. We're in quadrant 3, so sine is negative. So sine is opposite over hypotenuse, but it's negative 2 root 6 over 5 because we're in quadrant 3. And sine B is negative root 5 over 3, again because we're in quadrant 3. These don't have to be in the same quadrant, just so you know. But I just made it easy on us right there. So sine A is negative 2 root 6 over 5. Cosine B is this, so negative 2/3. Plus cosine A, we were given, negative 1/5. Sine B, we just calculated, negative 5 over 3. We do have like denominators, so what's our denominator? And then a negative times negative is positive, so I have 4 root 6. Negative times negative is positive plus root 5. And that is that quantity, so that's our answer. So after I figured out these two things, this is going to be easy. This is cosine A, cosine B. What's next? Minus sine A, sine B. Once you have these two memorized, very easy, especially after we get the difference rules in there, going to be pretty confusing.
Oh, this is just the sum rule.
Yeah, this is just the sum rule.
Yeah.
But with the formula is slightly different for the difference rule, but the process of figuring these out is the same. It's the same process, but the formula is a little bit different. All right, cosine A is negative 1/5. Cosine B, negative 2/3. Minus sine A, negative 2 root 6 over 5. Sine of B, negative 5 over 3. Which we got from our triangles. Don't forget, like, when in doubt, draw it out. You know, remember that? Draw your triangles and see what you can figure out. Right triangles, right? We don't want to do a law of sines or law of cosines things on these. We want to make it as simple as possible. Which basically your take-home test was on, law of sines, law of cosines, right? Finding the area of a triangle. All right, so we have 2 over 15 minus Now this is going to be a positive thing right here, but that's a root 5, right? So 2 root 30 all over 15. This is a minus. So these two negatives became positive, which I could have combined into one thing, 2 minus 2 root 30. Okay. You ready for the difference formulas?
No, it actually took me a whole piece of paper to do my notes on for once.
Now we didn't do any examples with tangent, but it's the same process. You just use the tangent formula.
And these are the difference formulas.
Yep. And how do I know? There's a minus sign right there. Alright, so in the sum formula for sine, it was sine of the first thing, cosine of the second thing. So that stays the same, but then we had a plus, but here we're going to have a minus. Cosine, when we had the sum formula, was cosine of the two, and then minus the sine of the two. But now, because it's a difference formula, it's actually just the exact opposite of that. Now with a plus sign. In tangent, pretty close again to the other one. But now, instead of a plus, a minus.
Can we do a tangent example for you?
Yep. We'll do a tangent example of these. Let's find tan. Let's do tan 75. We did sine 75, so why not tan 75? All right. So we'll actually split it up the same way. We're going to do this exactly. So we want tan 45 plus 30. So that's going to equal tan 45 minus tan of 30 all over 1 plus tan 45, tan 30. Now we need to know what tan 45 and tan 30 are. Tan 45 happens to be 1. If you don't believe me, you can verify that with your calculator. And with your calculator, what is the tan of 30? Huh? You got a 0.6?
0.573.
Okay, so that's either going to be root 3 or it's going to be root 3 over 3. Which of those equals that?
Root 3.
Is it root 3 over 3 or is it root 3?
I don't know.
30.
Oh,
Yeah.
It's right here.
Root 3 over 3? Campbell, could you verify? Put tan 30 on the calculator?
That's right.
Yeah, okay. I was going to say, the Casio will pop that out for you exactly. All right, so we know these, so we're just going to put them in. Tan 45 is 1 minus tan 30 is root 3 over 3 all over 1 plus 1 times root 3 over 3. Now we need to be careful that we follow the order of operations. Multiply before add and subtract. So 1 times this stuff is that stuff. So I have 1 plus root 3 over 3. And this is 1 minus root 3 over 3. Now this is bringing us to something that we did earlier in the year. We need to rationalize this. Or we need to at least get it a little bit simpler. The fastest way to do that, what's our common denominator here and here? Just 3. So I'm going to multiply top by 3 over 1 and bottom by 3 over 1. And that's going to simplify it down. So I get 3 minus root 3 over 3 plus root 3, which then we need to rationalize. How do I rationalize that? Times what?
3 minus root 3.
Yeah, 3 minus root 3. Because we do that. Is this the denominator? Now, rationalize we worry about when our denominator is a root. So we multiply by the conjugate, different in sign. So at top we get 9 minus 3, actually plus 3. Oops, no we do not. We do not get that. First thing times that, 9 minus 3 root 3, minus 3 root 3 is minus 6 root 3, then plus 3. And in the denominator, that's where we're going to get the 9 minus 3. So that equals 6. That equals 12 minus 6 root 3. Hopefully you see that we can cancel. Divide all those by 6, right? So we get 2 minus root 3. So this equals 2 minus root 3. A lot of simplifying there. After we do, we might come back to one like this and try a different tangent one just to work on it a little bit more. I want to spend a little bit of time on this. Let's make this chart. 0, 30, 45, 60, 90. These are and any multiples of these angles. So multiples of 60 would be 120, 180. Multiples of 45, 45, 90, 135. Multiples of these angles, you need to have in your head what the sine, cosine, and tangent are. Now they do repeat. So sine, cosine, tangent. So the sine of 0 is 0, the cosine of 0 is 1, and the tangent is sine over cosine. So 0 divided 1 is 0. As it just so happens, complementary angles, the sine and cosine are going to flip. So 90 would be the complement of 0. So those are going to flip. But then tangent is undefined because we can't do 1 divided by 0. 45. For both of them is root 2 over root 2. And tangent is sine over cosine. Well, these are identical. So that would be a 1. When you do 2 divided 2, you get a 1. So same thing. Now, what's the sine of 30? A half? What's the cosine of 30?
.866.
Okay. And you want to recognize 0.866 as being equal to root 3 over 2. So you can use if you can't memorize this table, which some people have a hard time with this, if you can recognize this 0.866 as root 3 over 2, that'll help you when it comes up. Now I need to do sine over cosine, so that's a half over root 3 over 2. And our common denominator is a 2. And then we rationalize that and we get root 3 over 3. So this is root 3 over 3. Now, 60 is the complement of 30, so these are going to switch. And then this is just root 3. Now, one way or another, you need to recognize these. I don't care the method that you... Aside from cheating, I don't want you to cheat, but I don't care the method that you figure this out. That means you memorize what root 3... What was root 3 over root 3? As a decimal?
0.577.
You can recognize, if you can recognize these decimal associations, then you avoid memorizing this. So I don't care your method that you do it. And the other one, root 3, what's that equal to as a decimal?
was it the 0.87 or 1.73?
Okay, and then of course you have your half. So if you can recognize these decimal associations, that's three things. Then you can just put the angle in your calculator and just be like, okay, that's root 3 over 2, or this is that 0.577. That's now if it's negative, you just throw a negative in front of it, right? Pretty easy. But you want to recognize these in order to do the questions. So let's say I want to find the sine of A minus B given sine A equals negative 2/3 and cosine B equals 4/5. I'm liking my 4/5 today. And this is in quadrant 3, and this one's in quadrant 1. Okay, so I have them now in two different quadrants. So we're going to have to be very careful about what we're doing. That means B, if B is in quadrant 1, sine is going to be what? And sine A is in quadrant 3, that means cosine is negative. Okay? So if I'm going to figure this out, well, I write down my difference formula. That's sine A cosine B minus cosine A sine B. What do I do next?
You have to find
The other ones. And how do I do that? Yeah, I draw my triangles. I have triangle A, triangle B, and I don't need to worry about their orientation or anything like that. Because it really doesn't matter. That's why I do this step. I just like, okay, where are these angles at? So A is opposite over hypotenuse. B is adjacent over hypotenuse. This is that 3, 4, 5 triangle, so this is a 3, so we get that one pretty easy. So that means I was missing the sine here. So sine of B is opposite over hypotenuse, and is quadrant 1, so it's positive. So that one's done. I need to get x here. X squared plus 4 equals 9. X equals root 5. So if this is root 5, I need cosine. Cosine is negative. So cosine of A, in this case, in this quadrant, cosine of A is negative root 5 over 3. So sine A, I just start plugging these in now. So negative 2/3. Cosine B, 4/5 minus cosine A. We just calculated negative 5/3. That's a 5. Sine B, 3/5. Hopefully you see that this is a common denominator, so I'll just write my 15, negative 8. And then this is going to be negative, but that will make it positive, so plus 3 root 5. And then we are done. Okay? Boy, seems like a lot, doesn't it? It is a lot. An easy question that you might be asked. Oops, I did this backwards. Sorry. I mean, we didn't talk much about this, but maybe you're given essentially the answer. This is a sum formula that equals sine 70, going backwards, right? maybe it's written like this. Now be careful. Cosine of that's the difference formula. Okay? Right? So you need to so recognize your sum and difference formulas that when you're given it, you can go back to what it would have been before it was split up. Okay? What if I had sine 15 cosine 20 minus cosine 15 sine 20? What's that going to equal?
Don't, well, yeah, 35.
Sine of
-5.
-5.
Oh, yeah.
It's a difference formula.
Yeah.
Okay? Or better, sine of 355. Make that a positive angle. Okay. But this, I guess, this technically is the answer. Okay, that's it.
No.
I'm not. I'm just stopping the recording.
Okay.